All right, geometry students, we're going to look at Unit 1, Lesson 21, and the lesson name is 180. We're going to be looking at triangles and how the angles add up to 180 degrees. We're going to be proving that. So the goal is I can prove the angles in a triangle sum to 180 degrees. All right, so a review of our vocabulary. Corresponding angles, remember corresponding angles are these right here. Remember they are on the same spot on two different parallel lines with the transversal. Alternate interior angles, here's an example. They're in opposite sides of the transversal on the inside of the parallels, and then they're on different parallel lines. Our third one is directed line segment. Remember, a directed line segment is a line segment that has a specific length, and then there's a direction in which it is pointing that we will take image to. A triangle is a three-sided shape containing three angles and no curves. The triangles we're going to look at contain only straight lines, so that's going to be important. All right, so this is kind of a difficult or a long warm-up, so please listen. If you need to, rewind it, pause the video, look at what's written on here, do the best you can. If you need to, you can't read this very well, go to the website on Google Classroom and pull up the warm-up and kind of get set up from there. But I'll take you through this and give an explanation of the directions. So, lines L and M, L here and M here, are not parallel and are cut by transversal right here. Tyler thinks angle EBF is congruent to angle BCD. So EBF right here is congruent to BCD right there. Because they are corresponding angles and using translation of B to C. So he believes these to be equal, and then he has 4 reasons for this. What you need to do is choose one of the 4 reasons. I don't care which one you choose. Just choose one of the 4 and then explain why that reason is either true or false. Now, some of these are good reasons. Some of them are bad reasons. What you need to do is figure out why it is good or bad and then explain that and bring that to class tomorrow. Remember, he is actually wrong, but just because he's wrong doesn't mean his reasoning is wrong. So the first reason that you could select is translation takes B onto C, so the image of B is C. So if we translate B down to C, it would put B right on C. Second, translation takes E somewhere on ray CB. So it takes E somewhere on CB because it needs to be translated by a distance greater than BC to land on the other side of C. So they're saying that it won't land over here. Image of F has to land somewhere on line M because translations take lines to parallel lines, and line M is the only line parallel to L that goes through B. So F has to go somewhere on M. Image of F, called F prime, has to land on the right side of line BC. So F prime has to land on the right side of BC, over here. Or else line FF prime wouldn't be parallel to the directed line segment from BC. So choose any of these 4 and explain why it is true or false and why you have come to that conclusion. And then we're going to use those statements to start our discussion about what went wrong for Tyler and how we can use this kind of understanding to understand triangles as we go forward. Thanks.